In this video, we present NeuroLines, a subway map metaphor for visualizing nanoscale neuronal connectivity. Neuroscientists in the field of connectomics are constantly acquiring large electron microscopy volumes to reverse engineer the brain and to find out how individual nerve cells are connected. However, detailed connectivity patterns are hard to see using standard 3D renderings of these volumes. We propose to abstract the complex branching and connectivity pattern of these neurites into a simplified representation inspired by 2D subway maps, as shown on the right. To be scalable, we have developed a multiscale view with 3 different tiers that show different levels of abstraction for neurites. The first view is the navigation bar, where each line in the navigation bar represents a single neurite. Neurites are color-coded and display either one or several user-chosen neurite parameters or show the original segmentation color. Additionally, this view allows sorting according to multiple criteria. Here, the user changes the sorting direction of 4 parameters, which is reflected in the navigation bar. A dynamic legend displays the key for the color-coded attributes and can be used to change the assigned colors. Next, the user decides to change the color coding to reflect a single element instead of the 3 sorting criteria. The middle view is the neurite overview window and gives a high-level view of individual neurites. It depicts neurites at a medium level of detail, without the full detail of its branches or individual synapses. Additionally, it can show detailed statistics for a neurite and all its synapses. All views allow navigating the data at different abstraction levels, from overview to detail. To do that, the views are linked by sliding focus windows that allow drilling down into the data from left to right. The right view is the so-called Workspace. It allows us to inspect individual neurites and look at their branching patterns, synapses, and synaptic chains in more detail. Synapses of a neurite are displayed as small nodes. When hovering over a synapse, a visual link to the connected neurite appears. Links to off-screen neurites extend to the screen borders. To explore the connectivity between neurites and their synapses, connected off-screen structures can be fetched and placed next to the current neurite. As an alternative, we can fetch all connected structures at once and sort them according to connectivity strength. If users are interested in a certain neurite, they can pin that neurite to the workspace. This guarantees that it stays visible, even when the remainder of the view changes. To analyze the length and branching patterns of neurites, we support relative scaling of all structures in relation to the pinned neurite. We also allow multiple neurites to be pinned to the workspace. The view can be zoomed and panned both vertically and horizontally. When zooming out, the neurite tree visualization is gradually simplified. When zooming in, gradually more details are shown. Since neurites can have many synapses, we cluster overlapping synapses. Here you can see the user zooming in along the length of a neurite. Notice how the synapse clustering gets continuously updated. Synapse clusters can be fanned out to allow users to inspect their individual synapses. Furthermore, synapses in a cluster always retain their spatial ordering. To allow the detailed inspection of synapses, NeuroLines has a synapse detail view that shows important synapse information and also includes a 2D slice view that is centered at the synapse location in the 3D volume. The user can either look at the original data or toggle the segmentation overlay. Furthermore, each synapse is linked to a 3D view. By clicking on the 2D slice view, the user automatically navigates to the synapse location in the connected and fully interactive volume rendering. Thank you for watching.